Hello everyone. Today in the last two sections of chapter 2, section 2.4 and 2.5, I'm going to show you some application of trig functions into applied problems. Alright, we're going to start this section today by examples. Actually, I'm going to go over a couple of examples, and from easy to harder ones, hopefully to help you to figure out how to use a trig to solve some problems. Basically, all the problems involving trig, you try to bring it back to a right triangle, okay? Because that's where we can use our trig functions, okay? And then whenever you have a right triangle, you know that we have a very famous theorem associated with, called the Pythagorean theorem. So this is A, this is B, this is C, then you got C squared equal to A squared plus B squared. And then given some sine and some angle, you can figure out. So let's start with the simplest one. If I give you C equal to 100, say 100 meters, and then A is equal to, I'll make it easy then, how about 10 meters? Short, okay? 10. And A is how about 6 meters? Question is, solve for the triangle ABC. And whenever you hear the word solve for a triangle, it means as they ask you to find all the size, measurements, and find all the angles. I know the angle C right here, immediately C is 90 degrees. Okay, I give it to you. The hypotenuse is 10. The side BC length is equal to 6 meters. And I have to calculate B, size B, I have to calculate the angle. Right here, let's call it beta, angle beta. And this is called angle alpha. Okay? So let's start with the easiest one. I can calculate the B first. How? I'm going to use the Pythagorean theorem. C squared is 10 squared. You see, that's why I wrote 100. Actually, I'm thinking of 10. Equal to A squared, which is 6 squared, plus B squared. 100 equal to, not degree, 36. Plus B squared, so subtract 36 on both sides, 64 is equal to B squared, so obviously be equal to 8. So you can solve for B. Okay, now we're going to find out the angles. You can use any trig function that you know. Let's start with sine. How about cosine or sine? Let's talk about sine then. I'll calculate angle alpha. I can say go with sine. Sine alpha. How do we calculate sine? We know that sine is opposite over hypotenuse. So 6 over 10, which is 3 over 5, I think it's 0.6. Now, all you have to do is use your calculator. Just want to remind you that in section 2.3, which I asked you to read it for yourself at home, you can look for this button in your calculator, sine inverse, and then plug in 0.6. Make sure that you convert all the units, your calculator back to degree, and you should have the answer. I'm going to do it in my calculator. It's a TI-84 Plus. Let's do it in here. Make sure that I got it right. Calculate degree. Alright. I'm going to do sine inverse. So second sine or sine inverse of 0.6. Now hit enter, and in my calculator it shows 36.86989765, so approximately equal to 37 degrees. That's how I calculate the angle. Sine alpha, so alpha is equal to sine inverse. So alpha is approximately equal to 37 degrees. So if I got this angle with 37 degrees, and I don't need to use trig anymore because I know that angle B and angle C is complement. So if this is 37, so this angle, you do what? Beta is 90 degrees minus 37, and that's going to be equal to 53, I think. And you have the whole triangle solved. This is 53 degrees. Okay, so this is the very first example, but it's pretty typical. For all kind of problem about solving triangle. You look for all the 3 sides and all the 3 angles. Pretty much. Now, let's get to the second example. which I saw on the book. Let me change the numbers. Say this. Okay, this is the ground. I'll show you this. You have a tall building. Just pretend this is the building, all right? A pretty tall building, and they want to measure the height of this building, so I don't know it. I call it X. Okay? What they know is a short building right here. All I know is the height of this short building. Let's make it, how about 10 meters, okay? And then there's a person stand on top of that short building. And then look up, they can measure the angle right here called angle alpha. Okay? Say alpha is equal to, I'll just make up a number. How about 55 degrees? And then that person also look down to the base of the tall building. And he knows the second angle. This angle right here is a 25 degree. Okay? So we know three things. The height of the small building. Two angles. From the level right here to the bottom, to the base of the big building, and to the top of the tall building. Alright? So we know two angles and that number 10. We want to calculate the height of the tall building. So let me try to bring it back here. Just a problem. Of angles. Okay? So this angle total right here is 80 degrees, not even 90 degrees. So, but we know that this angle right here is 90 degrees. Yeah? This one right here is 25. This is also 90. This one right here is 55. And the distance from here to here is 10. And you guys see 10 right here is the same? 10, right? This is 10. And how long is X? Okay. So we want to calculate X. But we know this 10 already. In other words, we need to calculate this length right here. So make life easy. Let me just label them with some numbers. Say A, B, C, D. Let's just label with letters. A, B, C, D. So I know BD here is 10. I know this angle right here is 25. And I need to calculate CD. Okay? That was the idea. So, what can I get from here? How can I calculate CD from here? I know 55 right here, so I know the sine, cosine, tangent of this angle. How about tangent? Tangent of this angle is CD over AD, right? Tangent of 55 degrees is opposite over adjacent. Okay, so if I want to know this opposite, I'm trying to calculate adjacent, AD. Okay, how do I calculate AD? Let's see. I got the angle right here. I got the sine right here. I got an idea. Tangent of the angle DAB. Tangent of that angle right there. And keep in mind this triangle DAB is a right triangle, 90 degree angle of D, right? So the angle 25 right here is DAB, this angle right here. Tangent of this angle is opposite over adjacent. So it's going to be BD over AD. So let's call this one as like little y, make it easy to write. So this is 10 over y. And this angle I know is 25 degrees, so this is tangent of 25 degrees. And of course, we can calculate tangent of 25 degrees using our calculator. Again, in here, I'm going to use my TI-84 Plus. I'll just simply hit tangent and then 25 degrees. One more time, don't forget to convert your unit of the calculator back to degree before you use it. And this is, let's do 3 decimal. 0.466. So I can calculate y from here. Y is 10 over 0.466, and that's equal to 10 divided by the answer 21.445. So I know the distance from A to B is y equal to 21.445. Now I know this side already. I can calculate CD. I'm going to use tangent again. Okay? Just go around sine, cosine, and tangent. Tangent of 55 degree. Tangent of that 55 degree angle right here is opposite over adjacent, which is CD over AD. And again, I'm going to use calculator to calculate tangent. Tangent of 55, 1.428, approximately 1.428. CD, I don't know. And AD, I know this is 21.445. So I can calculate CD. I'll take the answer time 21.445. This is about 30.627. Now I got this one is 10, this is 30.627. All I have to do is add 10 to 30.627, I'll get my answer. Alright. Let me write right here. How about this side? So the answer is BC equal to 10 plus 30.327 is going to be equal to 40.627, I'm sorry. 627, whatever the unit that they threw into you, could be meter, could be miles, could be kilometers, whatever. But it's not going to be kilometers, of course. Could be meter, could be yards. Okay? So pretty much, this is another example about how to use right triangles along with trig functions to solve some actual problems that you may see. Okay, let's work on another example. This time I'm going to talk about bearing. Bearing. Two types of bearings that the book introduced to you. Say bearing due to north is type number 1. Due to north, so it means what? You have the north, right? And then everything moves an angle from the north axis. So for example, we say what a shift is moving direction of bearing of say 25 degrees. Means what? You know the position of the shift right here, and then of course the north direction will never change, and then 25 degree go clockwise. 25 degree, that's a 25. Yeah. Okay, so this is the direction of the shift moving. Alright, this way, north. So if you have, they say this, if the shift's moving direction of 90 degree, very north, it means what? From the north axis right here, it's a shift right here, 90 degree, you go clockwise of the angle of 90 degree, this is the direction where the shift moving. Okay? But it could say, very, direction of 150 degree. 150, for example. Okay? What if a shift is traveling, bearing, I say, 300 degree? So how do you figure out 300 degree? Well, let's start from north, right? You go all the way. This is 270, 300 degrees somewhere right here. So this is the direction that's moving, 300 degree. Okay? That's one way. The second way is this, the second method of talking about bearing in our book is this. Beside north, we say what? Northeast, northwest, or what? Southeast, southwest. Okay? So, for example, it is direction north. Okay? And then a pushing is moving direction of north 35 degree east. Right this way. And how do we understand that? We have the north direction right here, so this left hand side is west, right hand side is east, so this is what? east, right? And this is south, right? And this is west, right? So say north 35 degree east means what? North right here, you go 35 degree to the east direction, so it's going to be somewhere right here. This is direction moving. Okay? What if you say north 85 degree east? North right there, 85 degree east, right there. 85 degree. See? What if you see north and then 40 degree west? So now north we don't measure the angle clockwise anymore. This time we have to go counterclockwise because we're moving to the west direction. So 40 degree is right here, 40 degree west. Okay? Similarly, if you have something like south 20 degree east, south 20 degrees, so you have to start from south right here. Now you go this way, angle of 20 degree east. Okay, this direction of moving. Okay, but that's just the way of people saying things in aviation air control. You guys gotta correct me on this because I may not be an expert. I'm not an expert in aviation. The actual terminology, the technical terminology that they use, I'm just using the terms that our books provide. So those are the two methods that our book shows. So I'll try to show you guys that way. Okay, doesn't matter what. It just go along with the right triangle and the degree, the measurement of the angles. Whatever the term they use, it won't go outside of our context. Okay, so let me look for another example. Let's see an example with pictures, so make it easy for us to follow. Okay, I see an example right here. So we have a ship stuck at a point and travels 55 kilometers, bearing of 27 degree. A ship bearing 27 degree, travel 55 kilometers. So let me draw right here. This where they start. This is my north direction, and bearing 27 degrees. So I've opened clockwise 27 degree, and then I'm gonna travel. This is 55 kilometers. Okay. And then after 55 kilometers, the ship gonna be right here. So let's call this point A. Travel all the way to point B, and the distance from A to B is 55 kilometers. And then travel on bearings of 117 degrees for 140 kilometers. So from here, so we're gonna start our compass right here and right there. And now I'm gonna open an angle of 117 degrees. Oh boy, it's gonna be an acute angle, right? This is 180, so 117 is that much. It's gonna travel. How far? 140 degree. 140 degree, and this angle is 117. And you're gonna travel 140 kilometers. I'm sorry. Yep. And the angle is 117 degree. Okay. And let's call this point C then. Question asks you to find the distance from A to C. Let's call it X equal to how much? All right. So what you know? There's a boat starting right here and travel 55 kilometers with 27 degree bearing. Okay, and stop at point B, 55 kilometers from A, and then now bearing an angle of 117 degree again, and then travel with a distance of 140 kilometers. Stop right here at point C. How far is that? And distance from A to C. Okay. Actually, this dotted line right here is a big hint. Recall what we learned before. We have something called what? Alternate interior angles, alternative exterior angle, that's gonna be a big help in here. Let me use red markers. Okay, you guys see that at point A and point B we have two compass pointing north. So two arrows right here actually parallel to each other, right? So if this angle is 27 degree, this angle right here is also 27 degree. You guys see why? Because they are alternating interior angles. Okay, and this is 117. You guys know what this angle is equal to? This is the supplemental to 117 because this is straight line, so the total of 180. So I'll calculate this by what? 180 minus 117, and that's gonna be equal to what? 63. Perfect. 63 degrees. So this angle is 63 degrees. What is so special about 27 and 63? They are complementary angles. Okay? Add up equal to 90 degrees. In other words, the triangle ABC is a right triangle. Awesome. And you have a right triangle, you know one side 55, you know the other side 140. The rest is going to be a piece of cake. X is the hypotenuse of x squared, going to be equal to 55 squared plus 140 squared. Plug in your calculator. Let me do it in mine. Quick, okay? 55 squared plus 140 squared equal to 22,625. So x is square root of 22,625. You take square root of this, you're going to have the answer. Let me do it quick. Approximately 150.416 kilometers. Okay. So the tricky part in this example is this: you're gonna kind of extend the compass a little bit so that you can see the relationships between the angles. Okay? Because if you don't draw it this way, it's kind of hard to figure out, isn't it? See? It's kind of hard to figure out. And of course, right now, they make it on purpose, just have the angles add up equal to 90 degrees. This is 27 degrees, and this angle is the 63 degrees, equal to 90 degrees. So you guys can use the right triangle. But I claim that it's not always the case that all the angles sum up equal to 90 degrees. Okay? And we're going to learn that later on. Let's save it for later lectures in our classes. Doesn't matter. Whatever angles they give you, that's how you go. You know one side, angle, then the other side. And I claim that by the end of this semester, you guys will be able to solve all kinds of those problems with any random angles given. No need to be super nice angle. Just that's the right angles of 90 degrees. Okay, that's an example. Let's look for another one. One more. Okay, I'll try to look for an example that got pictures, so easy to demonstrate. Distance between two ships. This is question number 25 in our book, page 87, section 2.5. Question number 25. Okay, we have the starting point right here. Say what? A ship leaves its home port and sails on the bearing of south 61 degree 52 minutes. Make it simple. 62 degree. This is south. Okay, so we say what? Southeast. South 62 degree east. Okay, so south right here, east right here, 62 degrees. So 62 degrees. This is the direction of the movement of the ship. And this angle is 62 degrees. Okay. And And then another ship reached the same point at the same time and sails the bearing of north 28 degree. Alright, so north is right here. North what? Northeast or northwest? Northeast. And then the second ship, this is ship number 1. And then ship number 2, north 28 degree east. You see something special in our brown for now. 62 plus 28 is 90 degrees, so pretty nice. So this is the second shift moving this direction of 28 degree northeast. Okay. And they give you some speed right here. The first ship sails at a speed of 24 miles per hour. The second ship sails with a speed of 28 miles per hour. And both ships sails for 4 hours. Okay? You know the speed, you know the time, you should be able to calculate this. And again, let me label this by A right here, B right there, and then C right there. So I'll calculate AB, which is the distance for the second ship sails, is 28 times 4, and that is 4 times 8 is 32, it's 112 miles. And then the second ship travel distance AC, what, 24, still 4 hours, so 24 times 4 is 96 miles. Now, you guys see, at the beginning of our course, they always try to give you very nice numbers to work with because they try to make a right triangle straight up. This is 28 degrees, this is 62 degrees, total is 90 degrees. So this angle right here gotta be equal to 90 degrees as well because the total of all the angles is gonna be equal to flat straight angles of 180. Alright, so we have a right triangle again, and BC is the hypotenuse of BC squared is equal to AB squared plus AC squared. I'm sorry, AC is equal to AB squared is 112 squared plus 96 squared. Now use a calculator one more time. Let me help you with this. 112 squared is 12544. 96 squared is 9216. Add up. That's equal to 21,700. I can't read one. 21,760. So BC is square root of that number, 21,760, and that's equal to 147.513 miles. Okay, and this is the end of this video clip for section 2.4 and 2.5. Hopefully, if you have a couple examples in these two sections, gonna help you to work on your homework exercises. If you have any question, again, please don't hesitate to ask. One more time, thank you guys.